We have a hot air balloon that's pulling up and we know just one cable. In the problem statement they give us the tension in AD and then we have to solve for the tension in all the other cables. All of this starts with splitting everything up into x, y, z components and then creating a unit vector. There's the length of the cable, square root dx squared plus dy squared plus dz squared. So there's dx, dy, dz for cable AD, and we're just getting that from the dimensions that are shown in the figure, and there's the unit vectors. So it's just dy over the length, dz over the length, and I can copy and paste that square root equation to show that the unit vector adds to 1. Once we have our unit vectors, we just multiply that by the force. Dollar signs keeps the cell constant, so you can copy the equation down. Checking to make sure that force still adds to 481. Okay, so we have the one cable we know filled in, and I'm going to copy those forces down into our force table. For the other cables, we don't know the force yet, but we can still figure out the unit vector. So here's AB. It's going straight down and back. And I'm getting that just from the dimensions. I'm going to copy that square root equation up there. Here's our unit vectors. So dx over the length, dy over the length, dz over the length. It's nice because you can just copy those equations over, and I think it's a little bit faster than typing it in your calculator. Here's the dimensions for AC. So we're going down in the y direction and then forward and forward in the x and z directions. So there's all of our unit vectors, nice and organized for us, and we just have to figure out what the forces are. Now what we're going to do is make sure all our forces add to 0. So everything in the x direction, the y direction, and the z direction all have to add to 0. Fill in what we know. We know everything about cable AD. We also can fill in some zeros. So here's everything in the z direction. It had only one unknown, so we can fill out what the z force for cable AC is. So once we have a piece of AC, we can copy and paste that over into our AC table. And when you know one piece, you know all of it. So the z component equals the unit vector times the force, or the force is the z component divided by the unit vector. Once you have the force, you can then get the x and the y components just like we did before. And now we have everything about cable AC in there. So we can take all of the rest of AC and put it in our force balance table. So there's the x force and the y force. Everything in the rows has to add to 0. Okay, so everything in the x direction adds to 0, the y and the z. Now we only have that one little cell in the x direction to fill in. So we know a piece of AB. So there's a piece of AB. We can just copy that over. And again, when we know one piece of it in the unit vector, we can get everything from it. So the total force is equal to Fx divided by the unit vector. And then the other y and z components, you just use those unit vectors too. So here's the rest of the forces, and now all that is left is the force of the balloon pulling up. Just make sure that everything adds to 0. This is also done in a PowerPoint, so go through the PowerPoint if that helps too.